Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at user-defined types and unions. It has been some time since we covered user-defined types. So today we're going to do a bit of a recap on how to set up and populate a user-defined type. And after that, we're going to cover the use of the union command. So first, let's create a simple user-defined type. We're going to store some information on an account. So we're going to create an account to store two things, a balance and a transaction count. So we can define the type by simply giving the type a name, in this case UDT account. There are two elements to this account, the first being the balance and the second being the transaction count. Both of these are defined as being long variables. We can reference this new user-defined type in our code by declaring a variable as that user-defined type. So here we've declared a local variable called uAccount as a user-defined type. As the name suggests, this is a local variable. But it's a local variable in which you have defined the structure of the data held within it. Now we can attempt to populate the data within this structure. By simply entering the uAccount, then a dot, and then the name of the element, in this case long balance, we can make that equal to 95.99. And the same with our transaction count, giving it a value of 1. This also helps to make your code quite readable. It's obvious that we're setting the balance on an account to a specific value. To prove that this data is now sitting within this construct, we can print the data out to our log. Since our log takes a string parameter, we have to use the format $ command to convert our balance and our transaction count into a string so we can append it to the word balance and transactions. If we try running our code now, we will see the balance appears as 96 and the transactions as 1. This might seem strange. We put the value in as 95.99, but it's coming out as 96. The reason for this is the variable into which we're putting this value is a long balance. This variable type does not hold decimal places, so it automatically round up to the nearest whole number. Since we're looking at storing currency, we'll want to change this to a currency type. So now we've defined within our user-defined type that the balance is now a currency, we can actually use that in our code. So if we try running our application again, we'll see the balance is now coming out correctly as 95.99. So we have stored two values in our user-defined type. So that's fine for a couple of pieces of information. But what happens if we need to keep track of a number of accounts? So since we have defined a user-defined type, we can create an array which is of that type. So now we have declared a 10-element array as UDT account. So each element of this array will have those two values stored against the element. So let's point this towards the first element in the array and populate it. So we've declared a local variable called element as a long, and we're populating that with the value 1. In order to populate this element, we can use exactly the same construct. In this case, we give the name of the array, followed by the element in brackets, and then a dot, and then the element within the user-defined type, in this case balance, and transaction count, just as we did before. So to prove that this has been stored within the array, we can print that out to our log. So here we are printing out the balance and the transaction count to our log. So if we run the application now, we will see we get exactly the same values coming out. In the array, our balance is 95.99 and our transaction count is 1. So we have stored two pieces of information inside our user-defined type. We can, of course, add additional elements to that user-defined type. However, one of the things you can do with user-defined types is nest them. So as we've stored within this account user-defined type, we may want to store some information about a user. This is likely to be more than just one thing. So we may want to keep track of the first name, the last name, and possibly an email address. So rather than add these elements to the account type, we're going to create another type purely for the user. So we've created a user-defined type purely for the user information, containing the first name, the last name, and an email address. All strings within user-defined types have to be of fixed length. So we've set the first name to be 100 characters, the surname to be 100 characters, and the email address to be 250. So having defined the user as its own user-defined type, we can now fold that into our account user-defined type by simply declaring another variable to be a UDT user. So how do we reference that in code? We can simply extend our data to have the name of the array, and in brackets the element we are wanting to populate, then a dot for str user, then another dot and the element within the user-defined type, followed by the data we wish to put in this case the first name and the last name. If you have many of these to populate, you can quite easily use the prefix command to save you a bit of typing. With the prefix command, you only need to put the data in once, as in the name of the array, the element, and the variable we're looking to populate. And then the specific element, being the first name and the last name, can then be specified in a single line. If you have a lot of these to populate, it saves a good deal of coding. So these two sets of code lines are exactly the same functionally. So to prove we've actually populated this data, we can again print it out to our log, just as we did before. As the information held within this user-defined type is a string, we don't need to use the format command. So if we try running our code now, we'll see we're getting the first name and the surname coming out quite happily. So if we wish to extend this concept further, and we want to store an account number for the user, a logical way of doing this would be to set up a variable within the user-defined type called account number. And if we say make this a 8-character string, this would work quite happily. So let's assume for the moment that the account number is actually comprised of two distinct parts. Perhaps the first 2 characters are a department code, and the remaining 6 characters are the actual account number details itself. If we left the account number as an 8-character string within this user-defined type, throughout the rest of the application, should you wish to determine the department number, the first 2 characters of the account number, you would have to put additional code in to work this out all the time. This brings us nicely to the union command. This can be used to actually split this information into different sections. So let's comment at this line of code for the moment, and we're going to create a union type. But first, we're going to create another user-defined type, which is going to be referenced within the union. So here is a user-defined type called account split. It comprises of a 2-character department and a 6-character account. This gives us our 8 characters. So how do we reference that in a union statement? Well, we're going to use the union command followed by the name of the union. In this case, we'll just call that account number. And we're giving this special union user-defined type 2 elements. One called full account, which is the full 8 characters, and the second one is str split. And this is using the type we created up here. So we have 2 things we can store information in. There's a full 8-character one in here, and there is also an 8-character one in here, which is subdivided into 2 characters and 6 characters. Now all this could have been done in a standard user-defined type, but the beauty of the union command is that the data that is held within here is not only exactly the same data that is held within here, it's actually in exactly the same memory location. So any reference to the full account will give you 8 characters. Any reference to the str split will either give you 2 characters or 6 characters depending on which of these you specify, but they will be coming out exactly the same memory location as the data held within full account. So it gives you the advantage of having 2 ways of getting at the information, but no additional overhead for storage. So having set up the union information, we now want to replace this account number entry in the account type with a new entry which will say that we want to store the account number as a UDT account number, referencing the union. So now that we have set this up, how can we reference this in code? So we will set up a new variable called account number as a string. We will populate that with an 8-character value, the first 2 characters being the department and the remaining 6 characters being the account number. We can then populate the element in our array using this syntax. The name of the array, followed by the element in brackets, then the account number, and then str full account, which holds the full account number, and we're populating our account number into that construct. To prove that's actually arrived, we can now attempt to print that value out to our log. And there is our value. We have the 8-character number coming out quite happily. Now, as you will see in the code, we have not populated the part of the user-defined type which defines the department number. So as the union section, which references the department, is pointing at the full account number, we should be able to pull that out without doing any additional coding, by simply referencing the str split as opposed to the str full and giving it the department number, which is the information we're after. So if we run that now, we will see that the department number comes out quite happily as the first 2 characters of the account number. So to reference this one element takes a fair bit of typing. However, we can do a shortcut in that and define a local UDT to hold the account number information. So we've now defined a user account user-defined type as our account number user-defined type. And we can populate this user-defined type by using this line of code, with the array, the element, and the str account number. And we can now print that out using a shortened version of the code. All we need to do is to use user_account.full_account and user_account.split.department. If we run the code now, you'll see the information prints out just as before. So since we've now defined the department, and we can pull that information out quite happily, we can put tests in our code now to test for the department. Say for example you have 2 major departments in your organization, and you wish to interrogate that and perform some conditional coding. So we can use a select case statement. So we're testing the user account split department, which as we've seen should be a 2-character number. If that gives us value 10, then we can do one piece of code. If it gives us something else, we can do some other piece of code. So if we run the code now, we'll see it has correctly identified that we are in department number 10. So in summary, what we've done today is we set up a number of user-defined types. We then populated them with some information on account details and user details. We've gone further and actually stored additional account information in a union, where the union has 2 ways of actually extracting the data. You can pull out the full account number, or you can pull out just the department number. And since these 2 elements are actually stored in the exactly same areas of memory, updating one will automatically update the other. Hopefully you'll find that code useful in your applications, but that's it for today. Thank you for watching.